Okay, so what do you got for me? 17. So chapter 7, right? Chapter 8. Perfect competition, that's right. We started chapter 9.
I'm going to do 17.
What's that?
17 wasn't a problem for chapter 8.
Oh, okay. Did we do the wrong one?
I did it.
Was
You did it too?
I thought it was start problem.
It is start problems, yeah.
It wasn't on mine, yeah.
Really?
It was 1, 2, 7, 8, and 12.
There's always 6 problems. So in the back there was no answer for it? On the line? Online?
There was no show solution or anything.
Okay.
It's always been one.
Alright, well you guys won't miss any points, but at the same time you need to still do it because it's a decent problem. So that's interesting. That's another little. So there was only 5 solutions on the online thing,
Yeah.
and obviously 17 had the solution back here, right?
Usually there's 6. This mine's been a weird chapter.
Yeah, and it's back here. Huh. I don't know. Well, let's go through it then. I guess what I'll do, since you guys don't have a problem, let me just get this thing fired up. Alright, so oopsie. Alright, so the canola oil industry, I'll put it on the overhead here in a bit, but is perfectly competitive. Every producer has the following long run total cost function, where Q is measured in tons of canola oil. The corresponding marginal cost curve is given by this. Calculate and graph the long run average total cost curve of producing canola oil that each firm faces for values of Q 1 to 10. Alright, so long run average total cost. I guess, first of all, Blake, was there a particular part of this that was troubling you more than others?
I just wanted to make sure that just go through the process.
Okay.
So just have someone else do it besides just looking at the answer.
Okay. So what do we do with part A? Let's see, 17. Where are you?
You want us to do this?
This is the problem you guys will need to do, yes.
I mean, right now, you want us to. What are you gonna go
I suppose we might as well if we're going to go through it. We'll kind of discuss it if you can knock it out while we're doing it. So long run average total cost is part A. Calculate and graph it from 1 to 10. What do we do with that? Little help, little help. Divide by Q, right? So we got average total cost. So we've got now long run average total cost is equal to long run total cost divided by Q. All right, so that one just kind of, all the Q's drop out. I'm not even going to write that one out. But we'll get 2Q squared minus 15Q plus 40. What will the long run equilibrium price of canola be? What do you think on that one?
Just find the version.
Find the what?
Find the, you have to find the long run marginal cost.
Yes, that'd be part of it. Ultimately, what do we need to have hold in the long run? Or what's our long run prediction in perfect competition for profit? It'll be 0. So what is the long run equilibrium price going to be equal to then in the long run? You can think back to our graph that we did. price equals marginal revenue, yes. But in order for profits to be zero, price equals, yes. But the minimum point, the average cost is what we want, because our profits are equal to total revenue minus total cost, being price times quantity minus average total cost times quantity, which could be rewritten as price minus average total cost times quantity. Now that profit equation never changes, so if profits equal zero, price must equal average total cost. We know quantity is going to be positive, or as long as price is greater than average variable cost. So those two things must be equal in the long run. So as Katie, I think, stated, we know where that's going to be if you graph out the long run average total cost curve. It's going to be at the minimum point.
So opposite of VO2A and figure out the vertex.
What's that? The minimum point. We wouldn't call it I'm not sure. Vertex, I think, would be like if it comes to an angle.
Yeah.
But the minimum point? You might be right. I don't know. Who's the math people? Is that a right term? Taylor, does that sound right? Vertex? You might know more than me, but otherwise the minimum. Yep, the minimum of the average total cost curve. And so how do we find that point? What's going on at that point? Good. Yeah, the marginal cost curve. So now they gave us that long run marginal cost, and so graphically our picture looks like this. Those two things intersect at the minimum. That then will tell you that price. That's how you solve for it. So set that equal to our average total cost. Before we work through it, let's just go through the rest of the problem, and then we'll just jump to the answer key. How many units of canola oil will each firm produce in the long run? So
The quantity that corresponds to what's happening, right?
good. So the quantity that's right here, if I start to draw a little more detail here, oops, I meant to do that. That quantity, okay? And suppose that the market demand for canola oil is given by that equation at the long run equilibrium price. How many tons of canola oil will consumers demand? All right, so
You just plug in that.
yes. So then you've got the equilibrium price already figured out. Yep. And then plug that into the demand curve. So with that information from part D, we're given a demand curve. We know that the price is this because that's the one that equalized or gave us profits equal to zero. Plug that price into the demand equation, and that'll give you big Q in the market. This was little q for the firm. Given your answer D, how many firms will exist when the industry is in the long run equilibrium? How many firms will exist? 4. How'd you get it?
By taking that 996 divided by 4 because each firm supplies 4 tons of oil.
Okay, so your answer up here for little q was 4.
Oh, sorry, 249. I took that at the long run equilibrium price, they're demanding 996, and each firm supplies 4 tons.
Okay.
996.
All right, so our 996 was there. So big Q is equal to the sum of the little q's for I equals 1 to n firms. So we're kind of using that information. I know that each firm does 4. And so if I take 996 divided by 4, I get my 249 firms, essentially. All right, let me just jump to the answer key, and you guys can ask questions from there.
I don't know if you guys already have gone over this, but for number 1, is the table in the answer key wrong? Yeah, because
What was the initial function? It looks like it's missing a parameter on the.
Oh no, I'm talking about for number 1. I'm on a different problem.
Oh, a different problem. Yeah, no, we haven't gotten to that.
Okay.
This is our first one we're looking at.
Yeah,
So there's your answer. Any questions on this? So there's that minimum point we solve for equals 12. Blake, are you okay with this one now?
Yep.
Running it through?
I'm not really 100% sure you got the.
B. So for B, if you set the long run marginal cost equal to the average cost and solve for Q, you'll get Q equals 4. Now if you plug that 4 back into either function, remember you go up to the marginal cost function or up to the average cost function, hang a left, and then that number will be 12 when you solve that problem. So plugging 4 back into the average cost function, hang a left, and that'll be a 12. And then you're using your logic that we know profit's got to equal 0. So that's why that's the answer. Because price has to equal average cost in the long run.
They're rounding up then, because 3.75, that's not confused.
Yeah.
Oh, they did some rounding.
15.4.
Okay. Okay. All right. Any other parts of this one? A little more coverage on? I guess the one I want to make sure you're clear on is that part E too. Did you guys get that? 249 firms. Okay, good. All right, anything else on that one, on this problem? Okay, Katie, what did you have?
On number 1, my table was different from the one in the back. Like the one in the back didn't make sense. It's like they got the numbers wrong. Yeah. So they gave us the marginal cost column for the problem, and then the back marginal cost column is different.
The number was
By 8.
996.
It's like I think they saw that it was 30 and they thought it said 38. Like in the front, the
Okay.
marginal cost is 30.
Oh,
That's the new back. That's the new table. When they add-
After they added the $8
the
for
E, whatever.
yeah.
Adding $8 to the marginal
This is
cost.
actually for part E.
Yeah.
That's what threw you. Yeah, I remember covering that last time. That was a little confusing, but that is the part E, not part A or whatever.
Okay, can we go over what the table should be for part A?
Sure. It sounds like you probably got it, because I think you're right with the,
Yeah, because
with the A part.
I didn't do the table for E, I just added A to the marginal cost I already had.
Okay. So here's the table. And they already gave you the marginal cost column even, right?
Right, that's why I got confused.
So I guess I'll just point out a couple things that kick this thing off. Fixed costs are 15, so total costs are 15.
Mhm.
Variable costs are 0.
Profit's
So-
negative 15.
Yeah, and so that's always the way to kick off a table like this, is to remember that, you know, there are no variable costs when we're producing nothing. So that's 0. And then from there, we've got marginal costs going up by 30. The only kind of costs that change are variable costs. So that means variable costs must have jumped from 0 to 30.
And then the next one would be 30 to 65.
And fixed cost, of course, is 15 all the way down the line, because they don't vary with quantity.
So it's 5.
So then
Total cost.
total cost would be 30 plus 15, 45, yeah.
So, but for the marginal cost on 2, would it be 5? Because 1 was 30.
The marginal cost is 35,
So it went from 30 to 30.
so variable cost that went from 30 to 35 is now 65. You're adding them, yeah. Because that's always the marginal unit. So 2 units was the first one plus the second one. So it's 65 for the 2 units of variable cost. Okay, that covers that one good enough?
Yeah, there is one thing. So the marginal revenue, it was consistently 50, but now I understand, because each additional one
price equals marginal revenue.
I was looking at it as marginal profit when I first looked at it.
Okay, any other ones on this homework set?
I have a question. Is marginal cost equal to the first derivative of total cost?
Yes.
Okay, can we already cover that?
No, we are not doing that. Why? Was this?
I feel like we had to do it in 7C. You need to know marginal cost and marginal cost.
There was a problem that, I remember you did have to do some calculus, so that wasn't, which problem was that, Adam?
7 on C, you need to know marginal cost, so you take the first derivative of the total cost.
Oh, yeah. Yeah, that's right.
On 17,
So that would be a problem you won't see on the test. That's correct.
so on 17, the one we just did for this one, those equations with the Q cubed, if you took the derivative of that, is that what is that? Is that what it is?
With the Q cubed, it would be you'd get the marginal cost.
That would be the marginal cost one.
Yep.
That's helpful.
Right.
Oh, yeah.
But again, for those of you freaking out, we don't have to know derivatives, but
Is that- but is
the
that
book has
how-
I think that's the only error that I can remember where they
Wow.
just, in the answer key,
Yeah.
put it down. What's that?
That's really helpful.
So now you know.
That's a derivative.
Well, that's why I like to tell you that, but
Total revenue, marginal revenue is the derivative of the total revenue.
yep.
That's really easy.
Yeah, marginal anything is the first derivative of the total whatever
Can you
function.
how many people don't know about derivatives? It's really easy.
Yeah, it really is.
Yeah, but our problems don't center around that anyway. So they'll give you the marginal cost. The only way this would change is instead of giving you the marginal cost function, they'd say find the marginal cost, and you'd have to do the first derivative of
Okay.
it.
So
That's
we never have to.
the only difference. Yeah, you don't have to do that.
That's the one thing I do remember.
But mentally, I mean, if you've gone through calculus, mentally, it might help you bridge a couple gaps. So that's fine. If it's helpful, great. Otherwise, it's nothing you need to know.
Well, then it just tells you that the marginal is dependent upon the total. That's what that tells us, my
Mhm.
right?
That's right. Which is no different, by the way, than if we have a total revenue function that looks like this.
That's one.
1, 2, 3, 4, 1, 2, 3, 4. Graphically, there's the marginal revenue of the first unit. There's the revenue of the second unit. And there's the revenue of the third unit. So they are tied together.
Yes.
Okay? Any other ones on this problem set?
Do you mind just brushing past 8 really quick?
8?
Regarding the areas you're looking for, kind of figure that out quickly.
Sure. Number 8. Maybe I'll just stick to the answer key if that's all right. Sounds like you got the gist of it. So, yeah, all these areas are important to know. So, all right, so on this graph, we have, what, price equal to 100? Was that the problem? Okay, so price equals 100. How does the firm maximize profits? By producing the quantity where the revenue generated by the last unit is equal to the cost of the last unit. So this is the marginal revenue curve. Jesse, Katie, you got something you want to review? Okay. Well, this one's important here. So, total revenue is price times quantity. In this case, it's 100 times 1,000, which gives you this area. So this rectangle represents total revenue.
Okay.
Total cost is given by the average total cost times that quantity. So K is the average total cost. So this rectangle represents total cost. Total revenue minus total cost gives you this green shaded area, which is the profit. So with all of these, it's all anchored around this quantity. This rectangle represents what? What does this rectangle represent? Yes, what kind of variable cost? Total variable cost, right. So the average variable cost per unit is M, whatever this number is. Maybe it's 50 bucks. 50 times 1,000 gives you total variable cost. So this rectangle represents total variable cost. What does this rectangle represent? Total fixed cost, because yeah, because the average fixed cost is the vertical distance here times the quantity gives you that rectangle, which is total fixed cost. So we can do that rectangle business with, you know, with any of the curves. All right. Anything else? Okay, well, let's jump back into monopoly stuff. So yesterday we showed, or Monday rather, we showed that the marginal revenue is not equal to price in monopoly. And graphically, what was the relationship? If we start thinking about kind of equations and graphs. The slope of the marginal revenue function is twice the slope of the inverse demand curve, or the demand curve. And so that was helpful in deriving the equation for the marginal revenue curve. So if an inverse demand curve looks like this, the marginal revenue curve is pretty easy to derive. It's equal to the same intercept minus 2 times, twice the slope, 2 times that slope number times Q. So marginal revenue is equal to that. That's all there is to it. It's a real simple little maneuver that you need to know that we didn't do in principles class, but that's how we're deriving the functional form for marginal revenue. So let's take a look at 9.2. Babe's Bats, BB, sells baseball bats for children around the world. The firm faces the demand curve of Q equals 10 minus 0.4 P, where Q is measured in thousands of bats, P is in dollars per bat. BB has marginal cost curve that's equal to 5Q. Solve for BB's profit maximizing level of output. Show the firm's profit maximization decision graphically. Okay.
So, on this problem,
Yep.
what would tip us off that it was monopoly?
Good question.
I don't necessarily see that.
So what would tip you off that it's monopoly? Good question. Anybody got any thoughts? That's a great question.
Looking at the demand curve,
Okay.
Looking at the equations.
So can we get it by looking at the equation? So
The industry demand and an individual's firm demand, since they're the same.
okay. So we kind of almost have to backdoor it a little bit. If we had a perfectly competitive situation, what would we need to know for the firm situation?
Were they producing it?
Like, how could you rewrite this problem to be, to get enough information to make it a perfectly competitive situation? What would you need to know? I think of a couple different ways, but I'm asking you to push the envelope here. So the firm faces a demand curve of this.
Marginal revenue equals multiple
Yes, I mean, that's the direction we want to head. Have you give you the market price. That would be one way. So the market price would just be given to you. Possibly with this thing, you could say that the market quantity is currently 1,000 bats. And then you could plug it back into the market demand curve, find out what the price is, and now that price would equal marginal revenue, and away you go, and you can solve it. Now, the real tipping thing here, though, is this second sentence. The firm faces a demand curve of this. In perfect competition, the firm faces the demand curve of this. The firm faces that demand curve because they're a price taker. So that's really the tipping point that makes it monopoly. Okay, good question. So what else? What do we got to do now? So the firm faces the demand curve of Q equals 10 minus 0.4P. What do you guys want to do? Solve for the profit maximizing level of output. Okay, marginal cost. Set what equal marginal cost? This one? Okay. How do you feel about that? What about marginal revenue? How does firm maximize profits? Finding the quantity where the revenue generated by the last unit is equal to the cost of the last unit. So marginal revenue equals marginal cost. Okay. So how do we do that? Why don't you guys start? You can work with your neighbor. I'll come around and see how you're doing. Have your book closed. Have your book closed. Okay. So, where to start? So what's this function? The demand. How does a firm maximize profits?
When the demand
Something equals something. How does a firm maximize profits, Adam? Marginal revenue equals marginal cost. You've got a demand curve, but you don't have a marginal revenue curve, so find that.
But isn't the marginal revenue curve the demand curve?
It's related to the demand curve. How is the demand curve related to the marginal revenue curve? How are they related to each other? Okay, how is marginal revenue and the demand curve related? Yes. The slope. Twice the slope. We just did it. That was the first thing we did today. What's that? Let's see, I don't have my answer here. Okay, did you go inverse? Okay, good. Yep. If you go twice, yeah. I'll go double check so you don't go too far without it, but that is the right concept, yes. Got it. You're off a little bit on your math somewhere, Adam.
Can we just solve for Q on a firm demand curve in order to find the inverse demand?
We already have it for Q.
I'm
Right
sorry,
there.
solve for P.
Solve for P, yes, to get the inverse demand
Okay,
curve.
so then this
Yeah.
is the inverse guy.
You just miss a, I'm guessing you just
I
missed
didn't
it.
divide this by 0.4, so this is actually 2.5.
What do you mean?
Yeah, there you go. Yes, that's right. For the marginal revenue.
Oh, yeah.
Yeah, that's right.
There's the inverse demand equation, so then we have to double this to get the marginal revenue equation. And then is that equal to?
Yeah, and you might want to solve those fractions like that. That's 1 over, or 1 divided by 0.4.
2.5, okay. So that's 5.
You guys back in action here? got some problems here.
Yeah, I didn't divide by.
Yeah, you got it. That's right. Yep, that looks good. Okay, you guys have come down with the quantity should be 2.5. Now at this point it might be helpful for you to jump into a graph too. You could start mapping this out. Once you've got the inverse demand curve, which I think all of you solved for, our intercept was 25. And we have a marginal revenue curve that's twice as steep. And then we've got this marginal cost function of what, 5Q? So that would start at the origin. And you solved for 2.5 there.
What if you had, what if you already times 0.4 by 2? I think I did that.
Like they gave you this equation,
Yeah?
and then all I did was just times that by 2.
Mm.
And set
No,
that.
because that is not the right one to multiply times 2.
Alright.
So you
So I
need to
just
have the
did it
you
backwards.
need, well, no, you need to have, you didn't solve for the inverse demand curve first.
Yeah, yeah.
So that is the regular demand curve. You need the inverse demand curve. So solve that equation for P,
Yeah.
and then you do your multiply times 2.
Mhm.
And you set that equation for the marginal cost to find the profit margin.
So that 2.5 effectively is inverse demand. Find out what P is.
Yeah.
To get B, yeah.
Yep.
That's right. You guys jump to B,
So B.
plugging it into demand,
Like
according
a-
to your picture.
Do we plug it into this one or the original?
Okay, what do you think? Look at your graph and tell me,
That's mine.
which one are you plugging it into? Mm.
That one? No? This one?
Look at your graph, tell me what we did in principles class.
10Q equals 25.
What do you mean, what are we doing?
So you correctly identified that's the quantity that maximizes profits, right?
Right.
So now we want to know what's the price that should be charged for that quantity.
So right here.
That's the marginal revenue. I agree with that. It's also the marginal cost. But what's the price we should charge? That's the marginal revenue. Is that the highest price people are willing and able to pay for 2.5 units? There you go. You had the dashed line already, so I thought you knew what you were doing.
Did I do my math?
Check out.
What? You plug it into the
Okay,
inverse
got
demand
it
curve,
over to
or
the other
inverse
side,
demand function.
0.4p.
That we figured out.
Got rid of the
Plug
q,
the Q in.
minus q plus 10, that's fine. Divide by 0.4, 2.5. Yeah, no, that's right, that's right. I would have, I mean, this is again just your preference, but I would have maybe put the 25 there and, you know, switched them around so you got it looking like with the
Like the
intercept.
inverse was original before the marginal.
What do you think is easiest to work with?
Oh, never mind.
How you doing? Okay, that looks good. How you guys doing? Okay, yeah, looks like you guys have got it. All right, I think you guys got it rocking and rolling. All right, so I think a couple takeaways from this exercise are to remember your principles and to remember the equations that belong with these functions too. Like this is the inverse demand curve, so we needed to have that P equals 25 minus, what was this, 2.5? Q? So Jesse was asking which one would be better to use. Well, technically you could use either one, but we're solving for the price, so if we've got Q equals 2.5, shove it in there, solve. So So this is our principal's picture. The price that the monopolist charges is $18.75. These numbers down here are something, they're just not the price. So we go up to the marginal revenue curve, hang a left, and we learn that that number is the marginal revenue. We go up to the marginal cost curve, hang a left, and we learn that that number is also the marginal cost curve. And so in this case, what were these numbers? Anybody do that? You weren't asked to do it, but what is the... Right, what's the marginal revenue associated with the second 2.5 unit? 12.5? So $12.50 was the revenue generated by the 2.5 unit. It'd be easier if this is 2,500 units, the 2,500th unit, right? Because whenever we're thinking marginal function, then that's the cost of the last unit produced. Okay. It's not asked in this problem, but what's the profits? What's the profit for this profit maximizing firm? What's the profit? 34? How'd you get that?
Multiplied quantity 2.5 times the price is 2.75.
Okay, so total revenue is 1875 times a quantity of 2.5, and then what'd you do?
And then I subtracted the quantity of 2.5 times the marginal cost, which is 5 cubed.
2.5
Times 5.
times 5. Okay,
34.37.
34.375. Does everybody agree with that? No? Why?
Because the marginal cost isn't the average cost.
Good. So what's the right answer to this problem?
Wouldn't it be that square between 875 and 1250 out to the quantity?
That square 875 here.
No, up. Between 875 and 1250.
875 and 2.
1875,
Oh.
sorry.
So that's where.
Oh, here?
Yeah.
Okay.
The average total cost.
I think that square would give you what Max had, right?
No.
No?
Could we take the, it's the opposite of the derivative of the marginal cost?
Let's not do derivatives.
We're gonna never
But
get the answer.
1250, isn't that what it costs you to make that many units?
Well, if we wanted to think about the marginal cost of 2.5 units, how would you need to do the math for it? Without using derivatives. Graphically, what would be the cost? So you can kind of think, what's the cost of 1 unit? How do we find the cost of, there's a number here, 1, right? We all agree there's a quantity of 1, the first unit, if you will, or whatever. How would you find the cost of that unit?
Go to the marginal cost curve and go left.
Good. Go to the marginal cost curve, hang a left. That would be the cost of the first. So the cost is kind of this vertical distance. The cost of 2.5 is that vertical distance. The cost of this one is this vertical distance, this vertical distance.
So I'm trying to draw it under the marginal cost curve.
Okay.
So 1/2
So
times
1/2
height.
But I still haven't heard the right answer. Nope. There's one right answer for this one. For profit. No. Good guess. Now you're getting more creative. It's a creative answer, by the way. It is a creative answer. So total revenue minus total cost.
And it's not 31.5?
Nope. Help me break this down.
Total cost is the average variable cost.
That's fine, you could work with that,
Total cost.
or you could leave it in totals, but
Oh, okay.
break this down for me. Total cost is,
Actual cost times Q.
yes, break it down. Variable cost, so total variable cost minus total fixed cost. So what's the answer to the problem?
Isn't it plus?
Oh, plus, yeah. Well, minus this plus this if you want to do it that way. So what are the profits for this firm?
Whatever they're based on.
It's a creative answer. That's the biggest hint I can give you.
Is it
Unknown. Thank you. That's the creative answer I was looking for. We don't know. There's not enough information to determine profits. There's not enough information to determine profits because marginal cost is the change in total cost over the change in quantity, but it's also, we learned, the change in total variable cost over the change in quantity. In other words, marginal cost does not reflect fixed cost at all. So there's not enough information from this problem to determine the total profit. So it's unknown, like it's an extra credit point.
So what did I tell you? What, not even anything did I tell you?
You did this. If you take the area, if you go with the area thing here, then you're really subtracting off the variable cost.
So I gave you that one.
Yeah, you got part credit, so you get a half point extra credit, and I round down, so that means nothing.
Thanks for playing.
All right.
Would we, so if we did take the derivative of the marginal, the inverse derivative or whatever, that would just give us the average variable cost?
Yeah, you don't have enough information. Yep, there's just not enough information. So I kind of threw a wild card at you. All right, 9.3. Let's get a start on this one. So we've got the Power Tires Company has market power. So that's what tells us it's a monopoly situation. And faces the demand curve shown in the figure below. The firm's marginal cost is 30 plus 3Q. What is the firm's profit maximizing output and price? Okay, so a little bit different approach on this one. What is the firm's profit maximizing output and price? How do we tackle this one? What's being shown in the picture? Okay.
Inverse to end.
Good. Yeah, I was going to say, what kind of demand curve is being pictured specifically? Is that the demand curve or the inverse demand curve? It's the inverse demand curve. I guess depending on how, that's not even totally a fair question, but if we look at that in terms of slope-intercept form, then it's the inverse demand curve. So write out the equation that reflects that. So what's that equation look like? P equals negative what? 3Q plus 300. So we got slope-intercept form of a line is our normal slope and intercept. Our intercept is a P. Our vertical, what we're measuring on the vertical axis is a P. Our intercept is 300 minus something Q. What's our slope? 3. So down, rise over run. We're rising a negative 300 over 100, so we get a 3. What is the profit maximizing firm's output and price? Sure. Let's Let's crank it up. This one should be easy now. Same as last time. What'd you get? Quantity 30, price 210. Looking pretty good. Quick draw McGraw over there. So we got 2 times 3 is 6, right? So there's your marginal revenue function, marginal cost they gave to you. Set these two equations equal to each other.
Q equals 30.
And Q equals 30. Shove that quantity back into the inverse demand curve. It's 210. Now let's just read. You don't have to do this one. We'll pick up here next time. But part B says, if the firm's demand curve changes to P equals 240 minus 2Q, while its marginal cost curve remains the same, what is the firm's profit maximizing level of output and price? So what's happening to the demand curve, the 240 minus 2Q? Graphically, what's happening? 240. So it's shifting down, and then what else? And then rotating out. So it's a funky shift. So try to visualize that. We had 300 up here. The new intercept's 240, but the slope has actually gotten flatter too. So D1 is here, D2 is kind of shifted down and out, gotten more elastic. All right, we'll pick up there next time.
You said the chapter 845.
8:45, yeah. Oh, and try to dress a little business casually.
No time.
No tie. Unless you want to. You might impress a few people if you want.
Did you want our homework?
Yes, I want your homework. Turn those in before you leave.